Have you noticed that a lot of these sinusoidal functions all follow the same pattern? You got a maximum, you got a minimum, and away you go. You got a period of time. Have fun. Okay, so look how this is no different. These are pedals on a bicycle. They're mounted on a bracket, of course. They're going to be centered, and it's 32 centimeters above the ground. So, okay, here's your graph. There's the ground. There's 32 centimeters. So guess what? I just gave you the D value. Oh my goodness. Yeah, it's the center. There's your D value. The pedals won't change. The top part of the pedal, of course, will change, and the bottom part of the pedal will change. But so what? Okay, now think about it. Okay, each pedal is 18.5 centimeters from the center of the bracket. So that means, take a look at this. You're going to have a maximum plus 18.5. So if you add 18.5 to this, this is a maximum of 50.5. If you take your pedal and push down now, you're going to go to a minimum, and your minimum value is going to be 13.5, right? Because this amplitude, look at that. I just gave you the amplitude being 18.5 centimeters. Oh my goodness. Now, check out what's going to happen. Your pedal, you always start, I don't know about you, I put my pedal in the top position, and then I start pushing down, and your pedal's going to cycle like that. Get it? Cycle, I'm funny. Okay, now, if you read this then, it says, assuming that the bicycle pedaled, check this out, 15 cycles per minute. So that means up and down 15 times per minute. Okay, so what does this mean? How long does it take then, right, for one cycle? So if you think minute is 60 seconds, right, and you got 15 cycles, okay, what does it take for one? How long does it take for one? Well, 60 divided by 15, like if you can't do that one, oh boy, folks. Okay, you know that this is 4 seconds per cycle. Guess what I just figured out? I just figured out the period. Okay, so your B value then is 2 pi over the period, which you know and I know becomes, reduce this, pi over 2. There's your B value. Oh my gosh, so easy. Okay, so your D value you know is at 32. Your amplitude you know is 18.5. Can we write an equation which describes a sinusoidal movement in terms of a positive and negative cosine function? Sure, let's start with the positive one. We're starting up here first. Okay, so the height as a function of time, remember, because these are sinusoidal applications, they have to be written as a function. Okay, so what's your amplitude? Your amplitude is 18.5, right? 18.5. There's your cosine. You're starting at the top at time 0. Your period is B value is pi over 2. You're starting at 0, so there's no shift. So this is just plain old time. Okay? Your center value is 32. Well, that makes it easy. Plus 32. There's your positive cosine. But what if you want this as a negative cosine? Okay, so in other words, you're going to start, instead of there, you're going to start here and do a negative cosine back down to here like that. Okay, so what? Okay, so let's do this. All you have to worry about is what is the shift. Okay, so think of the period. The period takes you 4 seconds to do a complete cycle. The cycle, of course, being from top to bottom is 4 seconds. So since we're starting down here, where are we? Oh, we're 2 seconds into the rotation, aren't we? So there's your movement to the right. There's your shift to the right of 2. So the height then, as a function of time, is now going to be a negative cosine function because this is the cup upside down. Okay, so negative, the amplitude is still the same. This is still going to be cos. Your period is still the same. But now you're shifting to the right 2 seconds. Okay, so put in the right 2 seconds. Shift to the right 2 seconds. Perfect. Easy peasy. Plus 32. Got the same values. Okay, now it says estimate the height to the nearest 1/10 of a centimeter of the pedal after 8 seconds. I'm going to pick the easier one. Just throw it in there. The height at 8 seconds is going to be 18.5 cos pi over 2. There's the 8 seconds that you're going to put in there, plus 32. I'm just going to throw the whole darn thing into my calculator the way it sits. Making sure this is in radian modes. Here we go. 18.5, right? Right? Cosine. There's my fraction. There's my period. Okay. There it is. Period of pi over 2. Bada boom. Bracket x, but my x now is going to be 8. Right? My time is 8. Close the bracket. Right? Plus my 32. There it is. Enter. I've got a time of 50.5 seconds. Oh, sorry, that's 50.5 centimeters. My apologies. 50.5 centimeters. So this is going to be at a height of 50.5 centimeters. Oh, how nice. That's easy. Okay, now it says estimate one of the times to the nearest tenth of a second when the pedal is 40. Again, remember, look at the difference between these two. You got to realize that this is a time, so you have to substitute in a time. This is a height. So that means this is 40 equals to 18.5 cos, right? Pi over 2 t plus 32. So you have to find the t value. Well, you can start playing around with this, making it a little bit easier of an equation to play with. I would subtract the 32 from both sides, right? So this becomes now, bada boom, this now becomes 8 equals to 18.5 cos pi over 2 times t. Then you don't have to worry so much about anything else. Dividing out an 18.5, I would do that. Divide out the 18.5 on both sides. Get rid of that. So this is 8 over 18.5 equals to, look how beautiful this is now. Cos of pi over 2 t. Oh, there's your y1, and you can actually put the y1 in as a fraction. And then there's your y2. Just find out where it intersects, right? That makes it super simple. So 8 over 18.5, I'm going to put that in as a fraction. 8 over 18.5, there you go. And then the other one, of course, is going to be, what did we have here? Cos pi over 2x. Okay, cos pi over 2 x. All right, there you go, close the bracket. Now, if you graph this, remember we had this calculator set up all weird for the last question. Just go to zoom and hit trig. Boom. There's your first, there's your y1, and here we go. There's your y2. And look, here's your pedal starting way up here, going through one complete cycle. There's your first intersect. That's what you're after, is that guy right there. Okay, so let's figure out that intersect. Second calc, okay? Find me the intersect 5. Mouse it over close to this, and enter, 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 and you find out that that's at 0.715, okay? You're 0.715 at that height of 0.43. Isn't that wild? Isn't that just great? Okay, so at what time? Your time, don't forget, is your x value. Your x value was, of course, 0.715. And it said, wait, did it say to the nearest hundredth? Nearest tenth. 0.715 to the nearest tenth works out to be 0.7 seconds. Well, that's not so bad. That was actually a pretty nice question, right?